Hello students, here I am going to explain about LED and optocoupler. So first we will see about LED. LED light emitting diode is a semiconductor PN junction diode. It is designed to emit light when they are forward biased. If we take ordinary semiconductor like silicon and germanium, when they are forward biased, electrons in n-type material and holes from p-type material moves towards the junction and they recombine. During this recombine process, energy is released. Most of this energy will be converted as heat and only very little will be converted as light. But in some compound semiconductor like gallium arsenide, gallium phosphide, most of the energy is converted as light. So these are used in the fabrication of LED. So next we will see about construction. This is P layer, N layer. See, on the top of P layer there is a metal contact. From that anode is taken out. In N layer also we have metal contact. Cathode is taken out from N-type material, N-type layer. You can see the metal contact is very much less compared to N-type layer. This is to allow more number of photons to go out of the diode. For this purpose only, the metal contact is coated very less on the p-type material. So when the p-n junction, this is the p-n junction. When the p-n junction is forward bias, recombine will start place. So during the recombination, photons are releasing. So this is about construction. Next, working principle. That's what p-n junction. When the p-n junction is forward biased, so here you can see positive is connected with the p-type material and negative is connected with n-type material. So when it is forward biased, the free electrons from n side starts moving from n-type to p-type, and holes from p-type starts moving from p-type to n-type. So these free electrons are in the conduction band and holes are in the valence band. So this starts the recombination process. So during the recombination, this electrons releases the energy in the form of photons. The emitted light tends to be monochromatic, means it will be in single color. A large exposed surface area on one layer of the semiconductor material permits the photons to be emitted as visible light. These are about working. So here you can see this is LED forward voltage. Between this we have connected one resistor. This is the resistor to limit the current flow through the LED. This is to protect the LED. The forward voltage across the LED can be 1.2 volt and 3.0 volt. It's depend on the material. The LED emits light in response to the sufficient forward current. An increase in ID corresponds proportionally to an increase in light output. That light output is also dependent on temperature. Light intensity goes down with a higher temperature. Application, there are so many applications for LED. We can say if you take a TV remote, there is a LED, digital calculator, traffic signal, digital watches, and automotive headlamps where we can see LED. Next, we will see about photocoupler. Photocoupler is also called as optocoupler and optoisolator. This device uses a short optical transmission path to transfer the signal between two isolated circuits. Optocoupler or optoisolator combines optical transmitting device at the one end and the photosensitive device at the another end. Both are in a single package which are coupled together. The optical path may be either air or any dielectric waveguide. So you can see here all the optocoupler devices are having two units, transmitting unit and receiving unit. In the transmitting unit, in the lamp or light emitting diode or laser diode can be kept. In receiving unit, any photosensitive device like photodiode, photo transistor, photo SCR, photo track, photo diode, any type of photosensitive device can be used here. Next, working. Here you can see this is transmitting unit, this is receiving unit. In the transmitting unit we have LED, in the receiving unit we have photodiode. So when the input voltage is applied, means when the LED is forward bias, positive is with the P region, negative is with N region. When the LED is forward bias, it emits the light. This is the working of LED. When it emits the light, this light will be detected by the photodiode is kept in the receiver side. So when the photodiode senses the detects the light, it produces the current. This is the working of photodiode. We have learned both of them already. So when the LED is forward biased, it emits the light. When the light is falling on the photodiode, it produces the current. So if there is any fluctuation in the input voltage, there will be a fluctuation in the output current. So that's why the combination of LED and photodiode is called optocoupler. You can see the pin diagram here. See, both the transmitting device and the receiving device, both are diode only, two terminal device. So only two pins are required. This is a pin diagram. So between 1 and 2 we connected LED. Then third pin there is no connection. Then in between fourth and fifth pin we connected photodiode. Again in sixth pin there is no connection. Application: photodiodes are used as a switches, SMPS, signal isolation, modem communication, and power control. Thank you.